Imagine a world where 70% of all software, apps, and systems you use daily are prone to security breaches. Shocking, isn't it? Yet that's essentially the reality we're living in. Insecure coding practices are not just prevalent, but alarmingly so, casting a long and ominous shadow over the digital landscape. Why should we care? Well, consider this. The implications of insecure coding practices are far-reaching and can cause havoc on multiple fronts. They can lead to financial losses, data breaches, and a severe erosion of trust. In fact, the global average cost of a data breach is now a staggering $3.9 million. And that's not even the tip of the iceberg. You see, insecure coding can be a ticking time bomb. It may not seem like a big deal in the beginning, but once exploited, the damage can be catastrophic. Just think about the recent high-profile data breaches that have hit the headlines. Many of them boil down to one common denominator: insecure coding. The harsh reality is that no software, app, or system is completely immune to security breaches. Whether it's a small startup or a multinational corporation, the threat of insecure coding looms large. It's a silent menace, often lurking in the shadows, waiting to strike when you least expect it. But it doesn't have to be this way. There are ways to mitigate these risks. There are techniques and strategies that can help developers fortify their code against potential security threats. In the world of coding, security is not an option, it's a necessity. So, how do you ensure your code is secure? Let's dive in. The answer to secure coding lies in understanding and implementing secure coding practices. Secure coding, in essence, is the practice of writing code for systems, applications, and web pages in a way that ensures the integrity, confidentiality, and availability of data. It's not just about making your software function correctly, it's about designing and creating it in such a way that it continues to function correctly under malicious attack. Think of it like building a house. You wouldn't just focus on making it look good and feel comfortable, would you? Of course not. You'd also want to ensure it's structurally sound and safe from potential threats like burglaries and natural disasters. The same principle applies to coding. Secure coding is paramount in the software development process. It's our digital lock and key, our virtual fortress against the rising tide of cyber threats. With the growing dependence on software in everything from our personal devices to our critical infrastructures, the importance of secure coding can't be overstated. So, what are secure coding practices? They are systematic measures and techniques that software developers use to prevent security vulnerabilities. They are the guidelines that help us navigate the vast sea of software development, steering us away from the treacherous waters of security breaches and data theft. These practices encompass a wide range of areas, from input validation and error handling to cryptography and session management to architecture and design. They're about more than just writing code. They're about understanding the environment in which the code operates, the threats it might face, and the ways in which it could potentially be exploited. These practices are not just a one-time thing, they're a continuous process, a mindset that needs to be integrated into every stage of the software development lifecycle. They're not about finding and fixing vulnerabilities after the fact. They're about anticipating and preventing them before they can even occur. Secure coding practices are your first line of defense against potential threats. But what are these practices? Stay tuned. To fortify your code, you need to understand CAPEC, CWE, and Mitre Att&ck. These are not just fancy acronyms, but powerful tools that aid in identifying and mitigating common security vulnerabilities. Let's start with CAPEC, which stands for Common Attack Pattern Enumeration and Classification. This is a comprehensive dictionary of known patterns of attacks. It's a resource that helps software developers understand how adversaries exploit their systems. It's like a manual of the enemy's strategies, helping you anticipate their moves and build stronger defenses. On the other hand, we have CWE, or Common Weakness Enumeration. If CAPEC is about understanding the enemy's tactics, CWE is about understanding your own vulnerabilities. It's a community-developed list of software and hardware weakness types. It's like a mirror that reflects the potential chinks in your armor. By leveraging CWE, you can identify common mistakes and pitfalls that might compromise your system's security. Now, let's move to Mitre Att&ck, which stands for Adversarial Tactics, Techniques, and Common Knowledge. This framework takes a different approach. It's a globally accessible knowledge base of adversary tactics and techniques based on real-world observations. It's like a regularly updated atlas of the cyber threat landscape. By using Mitre Att&ck, you can understand the latest threats and adapt your defenses accordingly. But how exactly do these frameworks help secure your code? Well, they enable you to anticipate, identify, and mitigate vulnerabilities. CAPEC allows you to anticipate potential attacks by providing a catalog of known attack patterns. It's like having a bird's-eye view of all the possible ways your system can be exploited. This enables you to design your software in a way that these attack patterns become ineffective. CWE, on the other hand, helps you identify the weak spots in your code. It's like having a flashlight in a dark room, illuminating the areas where bugs and vulnerabilities might be hiding. By knowing these weaknesses, you can take steps to strengthen these areas and prevent potential exploits. Finally, Mitre Att&ck helps you mitigate threats by providing a knowledge base of observed adversary tactics and techniques. It's like having a spy in the enemy's camp, giving you insights into their plans. This allows you to improve your defenses and respond to threats effectively. To summarize, CAPEC, CWE, and Mitre Att&ck are three powerful tools that can help you secure your code. CAPEC enables you to anticipate attacks, CWE helps you identify vulnerabilities, and Mitre Att&ck aids in mitigating threats. Each of these frameworks provides a different perspective, and together they give you a comprehensive understanding of the cybersecurity landscape. But remember, knowing these frameworks is just the first step. Applying them in your coding practices is what truly makes the difference. It's like having a map. It's useful, but only if you use it to navigate. These frameworks provide a roadmap to secure your code. Now let's see them in action. Now, it's time to put theory into practice. Welcome to the fourth stage of our journey, where we'll dive into the practical implementation of secure coding practices using CAPEC, the Common Attack Pattern Enumeration and Classification. CAPEC provides a comprehensive and consistent methodology for identifying, collecting, refining, and sharing attack patterns used by attackers to exploit software. By understanding these patterns, we can make our code more robust against potential threats. Let's start with a simple but all-too-common vulnerability, SQL injection. This is where an attacker manipulates a data query in a way that can read or modify sensitive data, or even execute arbitrary code. To mitigate this, we need to sanitize our inputs. This means checking and cleaning data before it's used in a query. CAPEC provides a detailed attack pattern for SQL injection, so we can understand how an attacker might try to exploit it, and thereby how to protect against it. Moving on, let's consider cross-site scripting, also known as XSS. This is a type of injection where malicious scripts are injected into trusted websites. These scripts can then be executed by the victim's browser, leading to potential data theft or other harmful actions. CAPEC provides several patterns for XSS attacks, including stored and reflected variants. By understanding these patterns, we can ensure that our code is resilient against such attacks. Next up is cross-site request forgery, or CSRF. This is a type of attack that tricks the victim into submitting a malicious request. It uses the identity and privileges of the victim to perform an undesired function on their behalf. To mitigate this, we need to implement anti-CSRF tokens in our applications. These tokens are used to ensure that the person making a request is the person they claim to be. Again, CAPEC provides a detailed attack pattern for CSRF, helping us to understand and prevent such attacks. Another common vulnerability is insecure direct object references, or IDOR. This is where an application exposes a reference to an internal implementation object, such as a file, directory, or database key. An attacker can manipulate these references to access unauthorized data. To prevent this, we need to implement access controls and ensure that all references to objects are secure. CAPEC's attack pattern for IDOR provides valuable insights into how such an attack might occur and how to protect against it. Lastly, let's look at security misconfiguration. This is where an application is vulnerable due to insecure default configurations, incomplete or ad hoc configurations, open cloud storage, misconfigured HTTP headers, and verbose error messages containing sensitive information. To avoid this, we need to ensure we have a secure configuration process in place and regularly update and patch all systems. CAPEC's attack pattern for security misconfiguration helps us understand the potential pitfalls and how to avoid them. While we've only covered a handful of coding vulnerabilities, it's important to remember that there are many more out there. CAPEC serves as a valuable tool in understanding these vulnerabilities and how to mitigate them. It's not just about fixing bugs, but about understanding the underlying patterns of attacks and building our defenses accordingly. Remember, secure coding isn't just about preventing attacks, but also about building more reliable, robust software. It's about instilling confidence in your users that their data is safe in your hands. It's a commitment to quality, to best practices, and to continuous learning and improvement. With CAPEC, you've taken a big step towards more secure code, but there's more to secure coding. Stay tuned as we continue to dive deeper into the world of secure coding practices. In the next scene, we'll cover more techniques and principles that will help you fortify your code against potential threats. Until then, happy coding! Ready for more secure coding techniques? Our journey into secure coding practices continues. In the previous scene, we've delved into the basics of CAPEC, a comprehensive repository of attack patterns. Now, let's shift our attention to another crucial framework that aids in mitigating common coding vulnerabilities: Common Weakness Enumeration, or CWE. CWE is a community-developed list of common software security weaknesses. It serves as a common language for describing these issues and a standard metric for assessing and discussing them. As we unravel the intricacies of CWE, it's important to remember that knowledge is power. The more we understand about the weaknesses that can compromise our code, the better equipped we are to prevent them. Picture this: you're building a towering castle stone by stone. This castle is your code. Now, wouldn't you want to know if there are cracks in the walls or weak spots in the foundation? That's precisely what CWE does. It helps you identify the cracks, the weak spots, and the potential points of failure in your code. But CWE doesn't just stop at identifying these issues. It also provides potential mitigation strategies. In other words, it tells you how to fix the cracks and reinforce the weak spots. As a result, your code becomes as robust and resilient as a fortress. Now, let's take a closer look at some common vulnerabilities that CWE can help us mitigate. The first on our list is cross-site scripting, or XSS. This occurs when an attacker injects malicious scripts into web pages viewed by other users. It's like a wolf in sheep's clothing, masquerading as harmless but causing havoc behind the scenes. CWE provides us with mitigation strategies for XS, such as input validation and output encoding, which can help us prevent such attacks. Next, we have SQL injection, another common vulnerability. Here, an attacker can manipulate your database by inserting malicious SQL statements. It's like handing over the keys to your castle to an invader. But fear not, CWE comes to our rescue again, suggesting practices like using parameterized queries and limiting database permissions to thwart SQL injection attacks. Then there's buffer overflow, where an attacker overruns the buffer's boundary and overwrites adjacent memory locations, causing unexpected behavior. It's like a dam overflowing, causing a flood. To prevent this, CWE advises on practices like bounds checking and using libraries that do not contain dangerous functions. Finally, we have insecure direct object references, where an attacker can manipulate references to internal implementation objects. It's like someone finding a secret entrance to your castle. CWE's mitigation strategies here involve access control checks and indirect object references. Are you starting to see the pattern here? With each vulnerability, CWE provides a roadmap to navigate the treacherous landscape of coding weaknesses. It's like having a trusted advisor by your side, helping you fortify your castle of code against all possible attacks. By implementing CWE in your coding practices, you're not just fixing problems. You're building a strong defense, a defense that anticipates and prepares for potential threats. It's a proactive approach that goes beyond just plugging leaks but ensures that the leaks don't occur in the first place. So there you have it, CWE, a powerful tool in your secure coding arsenal. A tool that helps you identify common coding vulnerabilities and provide strategies to mitigate them. a tool that takes you one step closer to achieving secure code. With CWE, you're even closer to achieving secure code, but there's one more framework to explore. Mitre Att&ck offers a wealth of knowledge for secure coding. Let's delve deeper into this treasure trove of information that's primed to enhance our secure coding practices. Mitre Att&ck, an acronym for Adversarial Tactics, Techniques, and Common Knowledge, is a globally accessible knowledge base of adversary tactics and techniques based on real-world observations. It's a valuable resource for developers, providing a framework to understand and anticipate potential threats and vulnerabilities in the coding process. So, how can we effectively implement Mitre Att&ck in our coding practices? To answer that, we first need to understand its structure. Mitre Att&ck is organized into matrices that are designed around specific target platforms. Each matrix contains a multitude of tactics and techniques that adversaries may use to compromise a system. Now, let's imagine we're coding a web-based application. We would refer to the enterprise matrix, which includes a variety of tactics such as initial access, execution, persistence, and defense evasion, among others. Each tactic has a set of associated techniques that provide further details. Understanding these tactics and techniques can help us anticipate and defend against potential threats. When we're writing code, it's essential to consider these tactics and techniques. For instance, if we're working on user authentication for our application, we might consider the credential access tactic. This tactic includes techniques like brute force, credential dumping, and forged credentials. By being aware of these techniques, we can write code that's robust against such attacks. Adopting such a proactive approach to secure coding, where we anticipate potential threats and code defensively, is a fundamental aspect of using Mitre Att&ck. It's not just about fixing vulnerabilities after they've been exploited, but preventing them from being exploited in the first place. But how do we stay updated with the ever-evolving threat landscape? Well, Mitre Att&ck is a living, breathing knowledge base. It's continuously updated with new tactics and techniques as they are observed in the wild. As developers, we need to regularly review these updates and adapt our coding practices accordingly. Now, it's important to note that while Mitre Att&ck is a powerful tool, it's not a silver bullet. Secure coding practices involve a multifaceted approach. Remember the common weakness enumeration, CWE, and the common attack pattern, enumeration and classification, CAPEC, we discussed earlier. They, along with Mitre Att&ck, form a comprehensive arsenal for secure coding. Implementing secure coding practices is a bit like building a fortress. Each brick strengthens the structure, and each technique we adopt fortifies our code. Mitre Att&ck is one such brick, a crucial one at that. In summary, Mitre Att&ck offers us a framework to understand potential threats, anticipate them, and code defensively. It encourages a proactive approach to secure coding where we aim to prevent vulnerabilities rather than just fixing them. It's a living knowledge base, so staying updated with its contents is key. And finally, it's part of a broader secure coding strategy, complementing other tools like CWE and CAPEC. By incorporating Mitre Att&ck, your code is now more secure than ever. But remember, secure coding is an ongoing process. Secure coding practices are not a one-time event but a continuous journey. So keep learning, keep evolving, and keep coding securely. By now, you've learned a great deal about secure coding practices. We've delved into the details of CAPEC, CWE, Mitre Att&ck, and other techniques that fortify your code against potential threats. But why is it so critical that we prioritize these practices? Let's explore. Secure coding is not just about keeping your software safe from attacks, it's about building a robust foundation that can withstand the test of time and adapt to evolving threats. It's about ensuring that the code you write today won't become a liability tomorrow. It's about creating software that can be relied upon, not just for its functionality, but for its resilience. Consider the alternative: insecure coding practices. They might save you a few hours in the short term, but they can lead to devastating consequences down the line. Data breaches, system failures, loss of customer trust. These are just some of the potential outcomes of neglecting secure coding practices. But when you prioritize security from the get-go, You're investing in the longevity of your software. You're ensuring that it can adapt and grow without being held back by vulnerabilities. You're demonstrating to your users that their data, their privacy, and their trust are important to you. And in this digital age, that's a powerful message to send. Moreover, secure coding practices enhance the overall quality of your software. They force you to think critically about your design decisions, to consider potential vulnerabilities, and to proactively address them. They encourage you to write clean, efficient, and robust code. And in the long run, that translates into a more reliable, more resilient, and more successful software product. So remember, secure coding is more than just a set of practices or techniques. It's a philosophy, a commitment to quality and security in everything you do. And in the end, it's an investment in the success and longevity of your software. Secure coding practices are not just about securing code, they're about building trust, enhancing quality, and ensuring longevity. Scene script. Secure coding is not a destination, it's a journey. A journey that begins with the very first line of code you write and continues with every subsequent line. It's not about perfection on the first try. Instead, it's about constant learning, improvement, and adaptation to new threats and vulnerabilities. This journey is about transforming not just your code, but your mindset to prioritize security. You've heard about the alarming statistics of insecure coding, and you've seen how CAPEC, CWE, and Mitre Att&ck can be implemented to bolster your code's defenses. You've learned the importance of secure coding practices in safeguarding your applications and protecting your users' data. Now it's time to take this knowledge and apply it to your own work. First and foremost, remember that secure coding is an ongoing process. With each new project, each new feature, and each new line of code, there's an opportunity to implement secure coding practices. Take the time to review your code frequently and look for areas of potential improvement. But how do you stay updated on the latest secure coding techniques? Well, there's no one-size-fits-all answer to this question. It depends on your personal learning style, your available resources, and your commitment to continuous learning. However, here are a few tips that might help. 1. Join a community of developers who are passionate about secure coding. There are numerous online forums, groups, and social media platforms where you can learn from others, share your knowledge, and stay updated on the latest trends and techniques. 1. Attend webinars, workshops, and conferences on secure coding. These events can provide valuable insights from industry experts, and they can also offer networking opportunities. 1. Read technical blogs, articles, and research papers on secure coding. Many professionals and organizations regularly publish content on this topic, and they often provide practical examples and case studies. 1. Enroll in online courses or training programs on secure coding. These resources can provide structured learning experiences and can cover a wide range of topics. 1. Experiment with different tools and technologies. Many software tools are designed to assist with secure coding, and trying them out can help you understand their strengths and weaknesses. 1. Finally, don't be afraid to make mistakes. Mistakes are an integral part of the learning process. When you encounter a security issue in your code, treat it as a learning opportunity. Analyze what went wrong, figure out how to fix it, and understand how to prevent similar issues in the future. Remember, secure coding is a journey that requires patience, persistence, and passion. It's a journey that's not just about protecting your code, but also about upholding the trust and confidence of your users. It's a journey that's not always easy, but it's undoubtedly rewarding. So take the first step towards secure coding. The journey might be challenging, but the rewards are worth it.